It seems as though our hypothesis that construction projects on campus would degrade the overall health and quality of the soils was not proven to be true through this experiment. Instead, analyzing data from our 5 overall measures of soil health, pH, nitrate, potassium, ferric iron, and humus, it appears that the soils taken from the construction sites actually proved slightly healthier on average than those from the undisturbed forest locations. Using recommendations from the USDA on exactly which measurement levels are best for healthy soils, it is clear that those soils from the construction sites registered a more neutral pH, a more average amount of potassium, and higher humus levels than those from the forest, indicating a higher level of soil organisms and overall nutrient availability. While the forest soils did score better with more desirable levels of nitrate and lower ferric iron concentrations, it is impossible to draw any conclusions pointing towards the forest soils being healthier than those found in the disturbed construction areas. One of the reasons for this lack of evidence is most likely due to the study's framework for how to gauge soil health. While our team used only the 5 measurements listed above, in fact there are plenty of other indicators for the quality of soil such as zinc, structure, and microorganisms. Perhaps if we had had the time to incorporate and analyze more of these measurements, we would have seen the separation in quality of health favoring the undisturbed soil beds rather than those disturbed. Another confounding variable may have been the depth of which we drew samples from our sites. With limited resources, we were only able to draw samples from depths of up to around 6 to 8 inches. While this provided ample materials to test and analyze, we were unable to measure the deeper layers of the soil, which are also very important to health and may have held different concentrations of nutrients and structures that could have indicated different levels of health not seen in the top layers. While our results proved inconclusive and unable to confirm our hypothesis, they do underscore the incredible nuance and complexity of gauging the quality of soils. As some soils are utilized differently by plants and animals alike, it is in fact difficult to even define what it means to have good quality soil. Moving forward, it is imperative to continue future experiments working to decipher this question of just how disturbance events such as construction projects impact soil health and quality. Resolving this question is not only important to further understand our world and the processes which affect it, but also to provide key information on how we can manage and maintain our human activities to promote a more sustainable local environment. If the results from this study stay consistent with future analysis, then it would seem that humans may want to focus attention on other drivers of soil degradation, rather than moderate disturbance events like construction, in order to more effectively tackle the challenge of maintaining a healthy ecosystem for all. If, however, further tests do indeed point to a correlation between an area's level of disturbance and its resulting soil quality, then it is imperative that we act on this knowledge to help decrease our frequency and magnitude of disturbance events in areas especially where soil health is an important part of the ecosystem.